All right, so moving on is chapter 1, section 3, and this is where we're going to talk about the intersection of a set of lines. So there are some finding different things, basically some steps to find the point of intersection. There are different ways of doing this, but our textbook wants us to solve it this way, and so we're going to by setting them equal to each other. So I'm going to read this off, and you can write it down. So first off, you're going to set both equations equal to one variable, and I can even change this and say to the same variable. Set the equations equal to each other. So if they both equal x or they both equal y, then you can set them equal to each other. You'll solve for the variable that's left. Then you'll take what you have for that one variable, substitute it into one of the original equations, and solve for the other variable. And then you have your solution, which is written as a coordinate, as a point. And what that is saying that that is where those two lines will intersect. So let's go ahead and get started with our first example. So it says, find the point of intersection of the two lines, x plus 2y equals 6 and 5x plus 2y equals 18. So it does not matter which variable you solve the equations for. You will get the exact same solution if you do all the mathematical skills correctly. So I'm going to go ahead, because the textbook does this, I'm going to try to stay consistent. So if you're following along a little bit with some extra notes, I'm going to solve both equations for y, for the variable y. So what I'll first do is I'm going to take the first equation, and it was x plus 2y equal to 6. I'm going to solve for y. So first thing I'm going to do is I'm going to subtract the x over, and I'm left with 2y equal to negative x plus 6. And then I'm going to divide everything by 2. That gives us negative 1/2 x plus 3. Next, what I'm going to do is I'm going to use the other equation, which is, I'm going to try to draw a line here so you can see they're separate. And we're going to have 5x plus 2y equal to 18. Solve for y. So I'm going to subtract the 5x over to both sides. Gives us 2y equal to negative 5x plus 18. Divide everything by 2. And that gives us y equal to negative 5/2 x plus 9. So now once you have this, you're going to take this, and you're going to see that this equation says y equals, this equation says y equals. Well, if I'm solving them together, I can use them together if I use them appropriately. And so if this says y equals all of this, and this says y equals all of this, I can set them equal to each other, because if y says this, I'm basically going to say if y is this, then I'm going to substitute in for this y, or vice versa. If y is all of this, I'm going to make this become that y over there. It doesn't matter which way you write it. So I'm going to write it over here to the side. So I'm going to say negative 1/2 x plus 3 equal to negative 5/2 x plus 9. So here is what you have now. You have one equation equal to the other equation, and you solve for that variable. Now there's a couple different ways you can do it. You can just start adding things over and moving things over because you're solving for the one variable. You can get rid of the fraction if you'd like. That way you don't have any fractions possibly until your answer at the end. And that's how I'm going to do it. I'm going to get rid of my fractions. If you don't want to get rid of your fractions, you just want to keep pounding through this, you still get nice values after one step, just not always does it happen. So I'm going to show you a more for sure way of doing things to make it easier. I think it's easier. If you don't want to get rid of your denominators, you just want to start adding things over, you would add the 5/2 x over, and you subtract the 3 over to basically say that's gone and that's gone. Now you have x equals in value, and you can keep pounding it through here. But I am going to say I'm going to multiply everything by my least common denominator here, and that's going to be 2. So I'm going to multiply this entire thing by 2. Now, by me doing this, what this is allowing me to do is I'm going to distribute this to every term in my equation. So I have 2 times negative 1/2 x. The 2's divide out, and I'm just left with negative x. 2 times 3 is 6. 2 times negative 5/2 x, the 2's they cancel out, they divide out. So I'm left with negative 5x. And then 2 times 9 is 18. Now I can add this over. Oh, I'm giving the answer away here. Actually, not even the answer. I think I wanted to do minus 6. So that way this is gone, and now this is gone. Now I have 4x equal to 12. Divide both sides by 4, and I get x equal to 3. That is not my answer, because what I'm trying to say is it says find the point of intersection. Well, that means that I'm going to be looking at a point, and x equals 3 is not a point. So my step said then you're going to take this here and substitute into one of the original equations. What I mean by that is you can substitute it into one of these original here, or you can go here because it's already set equal to y. So it really doesn't matter which one you substitute in for. It truly doesn't. So it's up to you, because this equation is just manipulated to be this one, and same thing here. This one is manipulated to be this one. So they are equivalent. But because I have a fraction and my y value here, or sorry, these slope-intercept forms, I'm going to take this 3 and I'm actually going to substitute in over here, just to make this a little bit easier without having a bunch of fractions in it. So I'm going to take x plus 2y equal to 6, and I'm going to substitute this in right there for x. So this becomes now 3 plus 2y equal to 6. And now you solve for your other variable. 2y equal to 3. Divide, you get y equals 3/2. So again, the end says you need to write it as a point. So I write points. We all write points. That's x comma y. So my x value is 3. My y value is 3/2. You can leave 3/2 as 3/2, or you can write it as 1.5. It's completely up to you. And what this is saying is that if I graph these two lines, if I graph this line here and this line here, then they will intersect at the point 3, 3/2. And there it is. I graph these, and you have the points where they intersect right here. 3, 1.5, which is the same thing as 3/2. All right, you also see equations written like this, and they'll have this brace on the side. It'll say solve the system of equations. You do it the exact same way. They're identical. Okay, in fact, look. I just have the same thing. This is the same exact question. It's just written differently. So instead of it saying find the point of intersection of the two lines, it'll say solve the system, and then it's written like this. So you'll go about the exact same way for our purposes. You set them equal to x or y, it doesn't matter, and you solve. So what I'm going to do is I'm actually going to set it equal to x and then solve and show you. So let's say I want to say this x plus 2y equal to 6, and I want to solve for x. That means I'm going to have x equal to negative 2y plus 6. And then let's say I take my 5x plus 2y equal to 18, and I want to solve for x as well. So I'm going to say 5x equal to negative 2y plus 18. Then I'm going to divide everything by 5. And I get x equal to negative 2/5 x, sorry, 2/5 y plus 18 over 5. Next, you would do exactly what we did before. You would set this equal to this, and then you would solve. All right. Now, again, fractions could be terrible. So if we set them equal to each other, we get negative 2y plus 6 equal to negative 2/5 y plus 18/5. Well, I mean, I want to get rid of my fractions, so I'm going to multiply all of this by 5. When I multiply all that by 5, 5 times negative 2y is negative 10y. 6 times 5 is 30, sorry, equal to. Now the denominators cancel out in the negative 2/5, or the denominator. The 5's divide out, so I get negative 2y. Same thing here, the denominator divides out, so I'm left with just 18. Now I have no fractions right now, and I just solve. So I'm going to add 2y over. I'm going to subtract the 30. And I'm left with 8y equal to 12. Actually, I should have negative 8y and negative 12. I apologize. Then you'll divide both sides by negative 8, and you get y equal to negative 12 over negative 8. That just reduces, right? 4 goes into both of those. You get the positives here. 4 goes into 12 3 times. 4 goes into 8 twice, so you get 3/2. That's our y value. Now what do we do with that? Now we take that and we substitute it into whatever one we want to. I am going to substitute it into this x minus 2y, I'm sorry, equals negative 2y plus 6. I'm going to take this, I'm going to substitute into there. So I'm taking this one right here. So x equal to negative 2 times 3/2 plus 6. You simplify this here. These two divide out, and you're left with negative 3 plus 6, which x equal to 3 now. Again, we write our solution as a point. X was 3, y was 3/2, and we get the exact same answer as we did previously. All right, so you have something called a supply curve and a demand curve. Supply curve basically says like what has to be charged for them to be able to produce what they're producing. The demand curve is what's high demand, and get back to where it's not. So example 2 says, suppose the supply and demand for a quantity is given by P equals 0.0002 Q plus 2, where P is in dollars. And Q is going to represent quantity, so you guys know. And P equals negative 0.0005 Q plus 5.5. Determine both the quantity of the commodity that will be produced and the price at which it will sell when supply equals demand. So what that says is, so it's you're determining the quantity of the commodity, which is Q, and the price, which is going to be Q comma P. All right, however it says. So Q again is the quantity. Sorry, I'll write better here. And then P is the price. All right, so if we go to this, now I want to say, what will it be when this supply equals demand? That's when this is, again, the supply and demand. So this is the supply, this is the demand. Demand, notice, is decreasing slope. Right? If we go back, our demand is going down, so the slope is negative. And then here, our supply, the slope is positive. So you know which one's the supply, which one's the demand, and we're going to set those equal to each other. So we're going to say, because they both already equal P, just like we did before, instead of equaling Y or X, they're already set equal to the same variable. So we're going to say 0.0002 Q plus 2 equal to negative 0.0005 Q plus 5.5. So what I'm going to do, I'm going to add the smaller variable over, and then I'm going to subtract the constant over. So you get 0.0007 Q equal to 3.5. Divide both sides by 0.0007. and Q equals 5,000. Now again, all this tells us is the quantity needed, but not the price. So this is the Q, right? This is the quantity. In order to find the price, I need to substitute it. And it really doesn't matter which one you substitute into. I'm going to substitute to the first one only because the numbers are a little bit smaller. They're all positive, and the 2 is a little smaller than the 5.5. So I'm going to say if P equals 0.0002 Q plus 2, and I know that Q is 5,000, if I multiply that, then this just gives me 1 plus 2, which is 3. So it's $3 because it says P is in dollars. These are my units. So you would say, and you would write the sentence out, if it says determine both the quantity of the commodity that will be produced and the price, you could say that the quantity needed for supply equal demand is 5,000 and the price will be $3. That is the sentence you will write.